All right, so for this homework, we want to come back here and visit our notes again. And we want to really highlight this new property of equality that we have. That means that if I have two sets of an equation set equal to each other, not only am I allowed to add, subtract, multiply, and divide each side by the same thing, I can go ahead and take the square root or any root or raise both sides to any exponent as long as they are the same. So when we go ahead and look at 5/6's homework, when I subtracted 8 from each side and I ended up with a negative, I knew this was suspicious. So I went ahead and did the work anyway, but when I go ahead and I do my check for this one, when I go to take my answer of -3 and say -3 plus 4 plus 8 is equal to 7, the square root of 1 plus 8 is equal to 7, guess what? In order for this to be true, I needed that to be 1, but the square root, or -1, but the square root of 1 is equal to 1. So when I have 1 plus 8 equals 7 or 9 compared to 7, no, they are not the same, so therefore there is no solution. Be suspicious whenever you're taking the square root and the answer turns out to be a negative. Alright, so we take a look at number 2. This one's pretty straightforward. Subtract 2 from each side, and then I square each side. Go ahead and I solve for x, and when I checked x, I only have one value to check, not a problem. So now I'm going to go ahead and look at number 3. Number 3, don't be confused that we were doing radical problems here. These ones are radicals, and this one is an exponent problem. We're going to be switching it up on you guys because then you get something like number 5, and it's both a radical and an exponent. So these ideas need to be able to be interchanged. Okay, so we'll go ahead and isolate our exponent by adding 724 to each side. 5 plus 724 is 729. When I take the 6th root of that, I have to remember my plus or minus because this 6 has an even value. So I set up my two equations. Y minus 1 is equal to positive 3. Y minus 1 is equal to negative 3. And then I get these two values for y. When I substitute them both in, using the calculator is an easy thing to check. What I want is 4 minus 1 to the 6th power minus 724. And I get 5, so I know that's a good answer. When I look at the next one, negative 2 minus 1 to the 6th power minus 724. I know this one's going to work out also because I'm going to get negative 3 inside of here, but when I raise that to an even power, I know it's going to work out and give me a 5. So those are both solutions because these both check. Okay, stop for a minute and think. What do we have here? We have a radical, which means we're going to be doing the inverse, which is raising it to a power. First, we need to isolate my radical expression. So I have the 4th root of x plus 2, and I know that that's going to be equal to 5. I'm going to take this whole expression to the 4th power, which means I wind up with just x plus 2. This comes out because these two cancel. Taking the 4th root and taking the 4th power are inverses of each other. 5 to the 4th power is going to be 625. When I subtract 2 from each side, x is equal to 623. I can test that under my radical sign to see if I got it right. So I'll type in a 4 first, and then I go to math to get my 4th root of, we'll put 623 in for x, plus 2, and I'll go ahead and close my parentheses. Needed to have the parenthesis, there we go. And then plus 9 outside of the parentheses. And I'm hoping for an answer of 14. The 4th root of my value for x plus 2 plus 9 And there I go, I got 14, so I know that that checks out. Take a look at number 5. I'm going to divide by 2. So I have x to the 3/2 power is equal to 125. There's two ways I can solve this, one with a radical and one with exponents. I'll show you both. This is going to be the square root of x to the 3rd is equal to 125. So I'm going to square each side, and I get x to the 3rd is equal to 125 squared. I'm going to take the 3rd root of that, and x is equal to the cube root of 125 is 5. 5 squared is 25. If I had decided to keep it in exponents, I could have said 2x to the 3/2 power is 250. Divide by 2, divide by 2. So far, nothing's changed. Now, instead of just squaring it, what I'm going to do instead is I'm going to take it to its reciprocal power. So my 2/3 power is going to mean that when I multiply my powers, a power of a power, I get x to the 1st power. And then I can come to my calculator and I can say 125 to the 2/3 power, and that's going to give me 25. So x is equal to 25. Either strategy will work for you. Okay, so we're going to subtract 7 from each side. Remember, you always deal with whatever's being added or subtracted first. 2x to the 3/4 power is equal to 23 minus 7 is 16. Divide by 2. X to the 3/4 power is equal to 8. You can go ahead and write this as the 4th root of x cubed and take an awful lot of steps by raising everything to the 4th power and then taking the cube root of it. If you choose to instead, you can say x to the 3/4 power is equal to 8. I'm going to multiply everything by the inverse. I have 3 divide by 4 here. I'm going to do 4 divide by 3, and that's going to give me x is equal to 8 to the 4/3 power. I can come over here and say 8 to the parentheses 4 divided by 3 power is going to be equal to 16. Now you know that's the same answer that we would have had if we had finished this problem, because this problem's next step is going to be x cubed is equal to 8 to the 4th power, and I take the cube root of each side, so x is equal to the cube root of 8 is 2 to the 4th, therefore x is equal to 16. Works out great for both sides. Alright, we're going to go ahead and take this. Alright, so I'm going to go ahead and multiply this by the inverse power. I think we agree that's so much easier. That's 4 to the 3/2 power. I can go ahead and simplify that by saying 4 to the parentheses 3 divided by 2 power. It's going to give me 8. X minus 1 is equal to 8, so x is equal to 9. If I were to do this problem as a radical, that means that I have x minus 1 to the 2/3 power is equal to 4. If I rewrite that, I have the cube root of x minus 1 squared is equal to 4. Cube each side. X minus 1 squared is equal to 4 cubed is 64. Square root, and I wind up with x minus 1 is equal to, here's our advantage to doing it the long way. when I take the square root of 64, I need to remember that's plus or minus. So when I add 1 to each side, I get x is equal to 1 plus 8, and x is equal to 1 minus 8. So I have two values here, 9 and negative 7. Let's go ahead and check and see if one of those is an extraneous solution. So we'll go ahead and clear out our calculator, and we'll do parentheses. We'll start with 9. 9 minus 1, parens, to the 2/3 power, and see what that is equal to. 4. Good news, we got that one right. Now let's check negative 7. So we'll have negative 7 minus 1, close parens, to the 2 divided by 3 power, and that's equal to 4 also. So here's what we need to remember. If we are raising to a power that has an even index, we need to make sure that we remember that we consider an alternative solution. So right here, we would have needed to include the plus or minus. So then we would have had both solutions, 1 minus 8 and 1 plus 8, to give me my full solutions. All right, divide by 2, divide by 2, x plus 3 to the 2/3 power is equal to 4. So when we go ahead and rewrite this as a radical, the cube root of x plus 3 squared is equal to 4. We're going to cube this, and then x plus 3 squared is equal to 64. Square root, here we go again. Make sure you remember that x plus 3 could be plus or minus 8. So x is equal to negative 3 plus 8 or negative 3 minus 8. So x is equal to positive 5 or negative 11. If you want to solve it using exponents, when you multiply by your inverse, because there's an even value in the denominator, that is actually taking the square root, and that's when you need to have your plus minus. So here you end up with x plus 3 is equal to positive or negative 4 to the 3/2 power is, of course, 8. And then we end up with our same answers down here. X is equal to negative 3 plus 8. X is equal to negative 3 minus 8. So our X is equal to our values of positive 5 and negative 11 still exist. Okay, so once you work on the back and check into the video for your answers, hit pause and try these yourself.